Now let's remember how to solve quadratics using the quadratic formula. Quadratic equations are of the form ax squared plus bx plus c. And when written in this order, there's a specific formula that we can use to solve any quadratic we want to. And there's a song to remember this formula that goes to the tune of Pop Goes the Weasel, if you're familiar with that song. So I'll sing it for you. There are much better singers on YouTube if you are interested in hearing this song sung differently. But this is how I learned the song and the formula, and I've never forgotten it. So listen, and I'll kind of mark on the parts of the song I'm singing as I sing them. So it goes, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So if you can memorize that formula, then you can do the quadratic formula to solve any quadratic equation you want to. So there's no limitations on this one. So it's a good place to start if you don't want to try lots of different options. Here's our first equation to solve. It's already in standard form, so we can easily see that a, the coefficient of the squared term, is 1, b, the coefficient of the linear term, is 5, and c, the coefficient of the constant, is 6. So, singing my song in my head or aloud, I write out the quadratic formula and substitute in the values of a, b, and c. So, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So notice I have to slow down a little bit on the b squared minus 4ac part, but you get it all in there eventually. So typically what I do in these problems is I simplify the radical first, meaning that I try to figure out what this value is so that I don't have to rewrite this a lot. You can, if you have a calculator, just type 5 squared minus 4 times 1 times 6 into your calculator and then take the square root of it. If we're looking for exact values, you need to simplify your radical using a factor tree or another method. But if it's a perfect square, you can simplify it quickly in your head. I know that 25 squared minus 4 times 1 times 6 is equal to 1 because 5 squared is 25 and 4 times 1 times 6 is 24. 25 minus 24 is 1. So for this portion, I'm taking the square root of 1, which is exactly 1. So the next thing I'm going to do is write down the rest of the equation, x equals negative 5, plus or minus, since I simplified this already, I know it's equal to 1, divided by 2 times 1 is 2. Now remember, for quadratic equations, we're going to have two solutions because the degree is 2. And the two solutions come from this plus or minus that's in the equation. So my first solution is going to be negative 5 plus 1 divided by 2. And you can use a calculator to simplify that or do it in your head. If you're using a calculator and putting it all in one step, make sure you put parentheses around the numerator. Otherwise, the calculator is going to follow the order of operations and give you negative 4.5. But the real answer to this is negative 2. Now, the second solution we get by using the negative version. Negative 5 minus 1 divided by 2. And again, if you're going to use your calculator, put the numerator in parentheses, but this is simple to solve using mental math. So I get negative 6 divided by 2 equals negative 3. So my two solutions to x squared plus 5x plus 6 equals 0 are negative 2 and negative 3. Let's try another one. Now notice that this one is not in standard form yet. So if I want it to be in standard form so that I can solve it using the quadratic formula, the first thing I'm going to have to do is relocate this negative 1. So I'm going to move it to the left-hand side with the rest of the terms so I can get a 0 on one side of the equation. So I have 5x squared plus 2x plus 1 is equal to 0. So now that it's in standard form, I can identify that A is 5, B is 2, and C is equal to 1. Now, substituting into the quadratic formula, I have x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now, once again, I'm going to simplify the radical first. So I'm going to determine what I get when I do 2 squared minus 4 times 5 times 1. Now, I know 2 squared is 4. And 4 times 5 times 1 is 20. So 4 minus 20 makes me take the square root of a negative 16. Now the square root of any negative number is going to involve getting imaginary solutions. We can separate the square root of negative 16 into the product of the square root of negative 1 and the square root of 16. Meaning that the value of the square root here is 4i. So if I substitute that into the equation in place of the square root, I get negative 2 plus or minus 4i divided by 10. Now, we are able to simplify this a little bit because if you notice, all of the terms in the numerator and the denominator are divisible by 2. So if I go through and divide all those terms by 2, I get negative 1 plus or minus 2i divided by 5. And I could, if I wanted to, write this as two separate solutions, but that's not generally what you'll see on multiple choice tests. It's perfectly acceptable for you to just write this as one solution. But if you like writing both solutions, you can. All right. For our next problem, once again, it's not in standard form, so I'm going to move everything in my equation to one side. Now, usually I like having a positive value on my squared term, but for the quadratic formula, that's not necessary. It's not going to cause more complications than we can handle. So I get 0 is negative 3x squared plus 18, sorry about that, let's fix that, 18x minus 6. So I can see that A is negative 3, B is 18, and C is negative 6. So substituting into the quadratic formula, I have x equals negative b plus or minus square root b squared minus 4ac all over 2a. Alright, so a lot of negatives in this one. Be careful with those. 18 squared minus 4 times negative 3 times negative 6. That's one that I use my calculator for. So the value of the square root is square root of 252. Now I also use my calculator to determine that I could divide 252 by 36, which is the biggest perfect square I can divide it by. When I divide it by 36, I get 7. So the square root of 36 times the square root of 7 is equal to the square root of 252, which means that 6 times the square root of 7 is equal to the square root of 252. So when I substitute that back into the quadratic formula, I have x equals negative 18 plus or minus 6 times the square root of 7 divided by negative 6. Now once again, notice that the numerator and the denominator, all of the terms are divisible by negative 6. You could divide by positive 6, but then you'd still have a negative in the denominator, which would need to be moved to the top anyway. So might as well divide by negative 6, which gives us negative 3 minus or plus the square root of 7. Now minus or plus is the same thing as plus or minus, so you can write that either way. You can leave your answer like this, or again, if you prefer, you can write two answers for this equation or this solution. Negative 3 minus the square root of 7 and negative 3 plus the square root of 7 are the two solutions for this quadratic. Now for the next one, it's already in standard form, so we can go ahead and identify A, B, and C, and then substitute into the quadratic formula. I'll spare you my singing this time and just substitute myself. One thing to notice is that b is already negative, so when I do negative b here, that's going to be two negatives, so negative negative 12. Negative times negative is going to give us a positive 12, so negative b is actually positive 12, which can be a little bit confusing when you're first getting used to it. Also, when I square a negative number, make sure you put it in parentheses if you're using your calculator. Otherwise, your calculator will square the 12, but not the negative sign in front of it. That's going to give you the wrong solution. So b squared minus 4ac divided by 2a. Negative 12 squared is positive 144, and 4 times 4 times 9 is positive 44 as well. So 144 minus 144 gives us 0. And the square root of 0 is just 0. So I have x equals 12 plus or minus 0 divided by 8. Now you may already be thinking that 12 plus 0 divided by 8 is going to be the same thing as 12 minus 0 divided by 8. And you're exactly right. When I add 0 to something, I get the same value back. So what ends up happening here is I have one solution for this quadratic, but it has a multiplicity of 2, which means on a graph of this function, we would have the vertex of the parabola at 3/2 on the x-axis. Finally, let's look at this quadratic equation. It's not in standard form yet, so I'm going to subtract to move the 7x to the left-hand side. So I have 4x squared minus 7x equals 0. Now, I can use the quadratic formula with this as well, but I still have to identify a, b, and c. In this problem, a is 4, b is negative 7, and because there's no constant term, c is going to be 0. So we can still do this, just make sure you identify your variables correctly. So we have x equals double negatives on the 7, so positive 7, plus or minus the square root of negative 7 squared, put it in parentheses, minus 4 times a times c divided by 2a. Well, when I simplify this, remember negative 7 squared is positive 49. Because when you square a negative, you get a positive value. So positive 49 minus 0 gives me 49, and I'm taking the square root of that to get 7. So I have x equals 7 plus or minus 7 divided by 8. So now I'm going to find my two solutions, 7 plus 7 divided by 8, and 7 minus 7 divided by 8. 7 plus 7 is 14, and I can simplify the fraction 14/8 by dividing both the numerator and the denominator by 2 to give me 7/4. Now, for the other one, 7 minus 7 is 0, and 0 divided by 8 is 0. So my two solutions here are 7/4 and 0.